If I look at a normal square root function, it looks something like this, right? It looks something like, agreed? Okay. And so we know the slope's going to increase as we work our way upwards. Agreed? Okay. Next question. What's the inverse? And since we had some stall in there, we'll remind you what the inverse is. If f of x equals x squared, what we do is we switch the x's and y's. This is how we find an inverse. Agreed? Remember that? So this is going to be y equals x squared. So this becomes x equals y squared. How do I solve for y? I take the square root plus or minus the square root of x equals y. So with that in mind, and knowing what you know, let's just do the positive ones for right now. Let's just do the positive ones right now. So the function g of x is inverse. We're going to define as the square root of x. Do the next 7 problems.
Inverse is just the interval, right?
Inverse is where you switch the x and y. That's what I just did.
Oh.
Yeah.
Yeah.
That's not too bad. Okay, by now you should be pretty close to already done a while ago. Terrible. Deal with it. All right. Mr. Nix.
Yep.
You should have a nice table. F of 1, we said was going to be what? 1. F of 2 is 4. F of 3 is 9, right? So these points, by the way, are 1, 1, 2, 4, 3, 9. Agreed? Okay, in inverse land, this strange place we live in, g of 1 would be 1. G of 2 would be, no, I didn't get G of 2, I get G of 4. G of 4 would be 2, and then G of 9 would be 3. So far, so good? And then in regular land, the derivative, which Kennedy gave us, is 2x, agreed? So then the derivative at 1 was 2, the derivative at 2 was 4, the derivative at 3 would be 6, agreed? All right. Walk me through these. The derivative of x, square root of x would be what?
1/2.
1 over 2 root x, agreed? So our derivative at 1 would be what? 1/2. And our derivative at 4 would be 1/4. And our derivative at 9 would be 1/6. Now, is everybody with us to that point? Because after this, we go on the crazy land involving the rabbit hole and strange teeth.
How'd you get 1 over
Yes.
2 radical x again?
G of x equals x to the 1/2, which is what the square root of x is, right?
Okay.
Derivative of that is throw the 1/2 out in front, divide, reduce the power by 1.
Okay.
That's a negative 1/2 power, so it goes to the bottom.
Or did you get the original x to the 1/2?
Sorry, what?
Where'd you get the original x to the 1/2?
Okay, so this is the inverse, which is what we spent the time doing,
So
figuring
that's
out.
just the inverse.
That's the inverse. How do you find an inverse, Walker? I'm gonna pause a moment because there's shit. Does anybody see a pattern in those derivatives? Mr. Bernard, do you see a pattern in the derivatives? They're the ones with numbers in them. The bottom's increasing by 2 on the right-hand side. The numbers are increasing by 2 on the left-hand side. That's a pattern, isn't it? It's even more interesting than that. Notice the derivative over here is 2. The derivative over here is... Bernard, you gotta be louder. Thank you. Derivative over here is 4. Derivative over here is 1/4. Derivative here is 6. What's the derivative over here? 1/6. So theoretically, there must be some way to take an original function, if I can find its derivative and find its values, and turn it into the derivatives for its inverse. How do I do that? What's the process? Anybody see it? Well, it's 1 over, right? So it is an inverse, right? So the inverse leads to an inverse slope, which makes some sense. Think about it this way. At this point here, my slope is, according to what we just did, 1/4. If you look over here, our slope right at this point would be 4. If you're looking at the picture, there's this one flipped this way, right? We're switching the x's and y's. So if the derivative is your change in y over change in x, then when you do the inverse, you change of x over change of y. So it would flip, right? So the derivative in inverse land is going to be the inverse, 1 over it. It's just going to flip. Does that make sense? Now it's trickier than that, but only slightly trickier than that. But this is the part that gets everybody right here. This is the item. If you look here, the derivative at 1 is 2. Derivative at 1 is 1/2. Okay, so you make perfect sense. The derivative at 2 is 4. The derivative at 4 is 1/4. Wait a second. Why are these two numbers different, the 2 and the 4? Different. You have to switch the x and y's in the problem as well. Okay? Because we're talking about inverse land, it's your y over here that we use to find over here. It is the y value that tells me my x value for the other one. So for example, if I want to find the derivative, let's say I want to find the derivative, and I want to do it the hardest possible way. We'll get to why this is going to be okay later. But I want to find the derivative of this. I want to find the derivative at, let's do 16. So how would I go about that? Here's what I'm going to do. I'm going to go back to my original function, which is the inverse. What would the inverse of g of x be? No, this is the derivative. This is the square root already. So what's the inverse of this? X squared. One person said it. Anybody else not with me? I'm pausing here because I'm doing deep things and I'm seeing lots of yawns. You with me, sort of? You have to be with me here. This is awful. Okay, I'll keep going. All right, so this is x squared, and so I would then take the derivative here. F prime of x equals 2x, agreed? And then I would look at it and go, all right, I need to know when the x value here is 16, right? Which would be my what value here? My y value. So when does this function give me 16? When x is what? 4, right? 4 squared. So the point 416 is important here. Agreed? So the point here is 16 points. So I'm going to take the derivative at not 16, but at 4. What's the derivative at 4? 8. So what's my derivative in inverse land at 16? 1 over 8. That's the problem right there. All the pieces right there. So the derivative is the inverse. Makes perfect sense, right? Because you're doing, instead of do I dx, you're doing dx dy, which would flip it. But the hard part, the thing that everybody forgets, is at the same time you switch your x and y's when you move from one to the other. The derivative of 4 over here refers to the derivative at 16 over here. Flipped. Right? Okay, so let's see if we can play this game a little bit. So, very first question, it says, example not real. It says, what would be the derivative of the inverse of the function of x to the cubed at x equals, can we switch that to, let's switch that to, not a leading number, 27. So it says, what would be the derivative of the inverse to the function f of x equals x to the third at x equals 27? And then right behind it, for the inverse, so we're not confused. For the inverse.
What do we write in the what does this mean?
What does this mean? It means that what? Let's do this. Let's do this. What does it mean? Back up. Back up. Sorry, a second. Going into the problem. What does this mean? So here it is. If I have f of x equals, so f of x means, let's do the inverse. The inverse of f of x is g of x. Agreed? If that's true, then the slope at x here, let's call it x1, is equal to the slope at x1 is equal to the slope of, whatever you put this. The problem is, any way I do this is going to get awful. At y1, agreed? Yeah. An inverse length. But the problem is this is already an inverse length, so that's not going to work either. So the notation is just awful. It would be 1 over f. That's not even going to work. Hold on. Let's do this better. Let's do this better. Let's do this better. Let's do this better. Let's do it the way I'm going to do it anyway. Here is real, and I call this inverse land or bizarro land. Agreed? Yeah. Inverse land or bizarro land. Okay, so in real land, f of x equals this. This is the inverse, agreed? Okay. Next step would be what? If there's a point x1, y1, then over in this land it would be y1, x1, agreed? The derivative at x1, okay, whatever that would be over here, the derivative at x1, I'm doing no, y1 would be equal to what? 1 over f prime of x1.
Okay.
So that would be the notation. That notation doesn't help much. Go ahead and do the problem while we still have kind of caught. So try the problem. It says, what would be the derivative of the inverse of the function of f of x equals x to the third at x equals 27 in inverse land? Yes, sir. Sure.